Right, so when we make electric circuits, we could make electric circuits for phones, for computers, and so on. And every place in the world has different batteries. For example, you've got AAA batteries, AA batteries, you've got batteries of different shapes and sizes, components of different shapes and sizes. So this bulb looks like this. You could have a different bulb looking completely different. So for that reason, when we're making and designing circuits, we need to design them so that everybody in the world can make them. For example, your phone could be made in Korea if it's a Samsung phone, or China, or India, or someplace else, and then it's sent here. If we had a different designs, different symbols in different countries, it'd be very hard to understand. So when we're making electric circuits, we have some symbols which are very, very easy to identify, and these are common circuit symbols for electrical components. So you've got 8 of them that you need to learn. Okay, so these are the 8 components. A cell is what we'd call a battery, a single battery in normal everyday language. A battery is actually plural. So in everyday language, you use the term battery, but what we actually mean is a cell. Battery is just a plural of a cell, and that's the symbol for a battery. We have switches to turn on and off our components. Those are those circuit symbols. A wire is represented by a straight line. A lamp is a circle with an X in it. Don't forget the 2 lines either side. An ammeter is a capital A in a circle, and a voltmeter is a capital V in a circuit. Okay, you need to learn and be able to write each one of those components. What I suggest you do is you take a couple of minutes, not now, but later on. It'll take a couple of minutes to learn each one of those, cover them up, or turn over the page, and in your summary section, you can try and reproduce them, and then turn back and see how many you've got correct, and then repeat the process. So that is the first task that you will do once this lesson is finished, is start learning those and using the summary section to help you self-quiz the answers. So we do that by checking them, learning them first of all, turning over the page or covering them up, and then trying to write them down again with the names, and then turn back and check what you've got. If you do it in your summary section, then you can use your green pen to correct any errors or to redo them. Do that 2 or 3 or whatever number of times it takes, but you need to have learned all of those circuit symbols. In a test, a simple question will be to be able to write down what the circuit symbol for, say, an open switch and ammeter is. So you'd be expected to know those and be able to draw circuit diagrams based on those. Okay, so that's your first task. Right, now, one of the things we do with electric circuits is we have to be able to take measurements of them. Like anything in science, we need to take measurements to be able to identify patterns and so on. Electric current is measured, and you can have a ruler to underline here. Electric current is measured using the unit called the ampere. So on line, so I'll finish my page here, can't see the line on this one here. The SI unit is the unit of current, is the ampere, capital A. So highlight or underline that section. Be careful that the symbol for the ampere is capital A, but the symbol for the word current is I. So when we're talking about the word current, in shorthand, we write down capital I, not to be confused with the unit for electric current, which is called, which is A. So again, highlight that line there. How we measure electric current is using an ammeter. All of these are called after the French polymath André-Marie Ampère, who lived in between 1775 and 1836. So the instrument, so the size of an electric current is measured using an instrument called an ammeter. So an ammeter is used to measure current. Now, our simplest electric circuit is called a series circuit, which I'll go back to figure B. And what we mean by that is series circuit. It has a power source, so the cell here, and there is one possible path for the current to flow here, it goes through the bulb and back to the cell. So a series circuit has only got one possible route for anything to flow through it. Okay, no branches, no place else to go. So imagine it like water flowing around in a circle. It just keeps flowing around and around and around, and the energy from the cell, which is chemical energy, is converted into the heat, and then that produces light in the bulb. Okay, and that just then flows around. Okay, so you will see the Appendix A2. I've done the experiment and I'll upload it onto SharePoint after this lesson. This is used to identify a rule for the current in a series circuit. So the idea is, cover up results because I don't want you to see those, is you will build a series circuit. Okay, so this is on page 39 of your book. Build a series circuit. Again, you will see, I'll put the video link on SharePoint so you can see how this is done yourselves. The series circuit contains a cell, an ammeter. Remember, the ammeter measures the current, okay, which flows through the circuit, a bulb, and then a wire back to the cell. And then circuit B is the same circuit, except this time there are two bulbs. So series circuits have one possible route from the cell through the ammeter, through the bulb, through a second bulb, back to the cell. Okay, so in this experiment, you measure the current at the points marked 1 and 2 for circuit A, and then at the points marked 1, 2, and 3 for circuit B. Okay, and then the result of this would be that we will actually see, is there something we can learn about the current in different parts in a series circuit. So the current will flow from the positive side, this side here, through the circuit, back around. Okay, current flows through the circuit. So the result of this is what happens the current in a series circuit. And what you should find, that the current in a series circuit is the same every place. Current does not get used up. Okay, I'll look at that results table and how that's produced in the links that you'll see in the lesson recording, which will be on SharePoint soon. Okay, so in a series circuit, current in a series circuit is the same at every point in a series circuit. Okay. Read through the information down on page 22, 23. Work your way through the knowledge and application questions after we have completed all of the online lesson. There's a cognitive activity to try as well. Use the summary pages to learn the circuit symbols. And I'll just pause the recording there.